Hello everyone, welcome back. This video I'm going to show you on Chapter 3 of Form 4 at Maths called Quadratic Function. Chapter 3 of Form 4 in SPM is actually related to, is closely related to Chapter 2 of Form 4. In the previous chapter, you have quadratic equation where in a general form, in order to express a quadratic equation in general form, it should be ax squared plus bx plus c is equal to 0. And this is the reason to why it's called equation, because it is equal to a number or is equals to 0. That's why it's an equation. Whereas for quadratic function, however, it will be a function of x. Let me use the previous the equation. In the previous chapter, we have fx is equal to x squared minus 3x plus 2. And this is now a function. It doesn't equate to any number. It's a function. Now, what can I do with this? In this chapter, you are going to deal with, you need to find out actually, what is the turning point, the maximum or the minimum. The method I'm going to show you in the following few minutes to get the maximum or minimum value, and then with the maximum and minimum value, how I'm going to sketch a graph from it. Graph sketching and finding range of value. So there are three things you want to do. One would be, you call it a turning point. Once you know how to get a turning point by using completing square, of course, that I'll show you in previous chapter, you may browse to my chapter 2. After you know how to find a turning point, how to make use with the information from turning point to sketch a graph. And lastly, that would be the range of value, or you call inequalities, quadratic inequalities. Three things you can do with turning point, graph sketching, and equalities. To start with turning point, in my previous video, I have it here. No, not this one. Here. Getting a turning point, we are actually make use of completing square. In completing square of the same equation, I plus the b over 2, I minus b over 2, and then this is the final result. And then of course equal to 0 is the equation. Then you find what's the x value. However, there are instances when they ask you for turning point or maximum minimum point. It's not a different approach, the same approach. Turning point by completing square. Penyempurnaan kuasa 2. Completing square. So to start off with is a revisit of the previous work. The function fx equals to x squared minus 3x plus 2. In order to do that, oops, it's not a bracket yet. Let me work it out here. It would be x squared. Rewrite the first one. This is 3. Instead of writing here, all you need to do is you plus the b, this is the b, a, b, c, this is the b, plus the b over 2 square, you plus something to it, you minus, or otherwise this function wouldn't be the same anymore. You plus something, you plus a term, you subtract the same term, then is basically the same function. That's why you have an equal sign to the previous line. It's equal because you plus a term, you subtract a term. The rest remain. Then from what we have learned earlier, this will be x. We'll copy this down to here, minus 3 over 2 squared. This 2ab will account for this already. Then we subtract 9 over 4 plus 2. And you solve it further. This is now different approach because we are looking for turning point. You solve this would be negative 1, 4, negative 1 over 4. And with this, you get some information. It is different from previously because previously we equate this function to 0 and you need to find out what's x. Whereas here is the general equation of a function, and based on here, I will be able to tell the turning point should be a minimum point, whereby if we were to compare with a general equation for completing square, it should look like this, where fx should be equals to a x plus p squared plus q. If I manage to arrange it in this form, they call it a general form. Therefore, I should be able to find out its turning point. Now, based on this function, I will be able to tell that the a is positive 1, positive number greater than 0. The p is negative 3 over 2, and q is negative 1. Now, if the value is more than 1, then that will be a U-curve. If I were to sketch it, positive y, 0, x. The a is more than 1, I know it's a U-curve. And the turning point should be, if I were to equate this whole term equals to 0, I equate x minus 3 over 2 is equal to 0. It turns out that my x are supposed to be 3 over 2. So that I know the turning point should be about 3 over 2. Y is negative 4. Maybe here. And my graph should look like a U-curve. How do I know that? Based on here. Simple. I equate this whole term equals to 0. Ignore the 2 and ignore the a. I equate this term equals to 0. And the file was x. And whatever leadings behind it would be the y value. This is a negative. 1 of 4 is negative. I know it's a U-curve because the a appears to be positive, more than 1. Therefore, I would know this is a U-curve. This is a turning point. Not all about that. Besides that, I'll be able to tell the axis of symmetry because the turning points serve also as an axis of symmetry. This is the axis of symmetry, whereby this point, this line will be x equals to 3 over 2. with a minimum of negative 1, 4. This is the first part by using completing square to get the minimum point, negative 302 and 1, 4, which is this point. P point is 3, 2, coordinate, negative 1 over 4. You might need to rewind to the previous minutes to look at this portion, this part, and this part, so that you have these two parts. This here to here is important. Now next, I'm going to show you on how to sketch a graph based on this equation. As you have seen earlier, what I showed here, in order for you to have a graph, whether U graph or N graph, I look like N, the graph should intercept at y-axis and x-axis. Well, previous chapter we learned b squared minus 4ac, a condition to tell if it intercepts at x at 2 point or 1 point, or it doesn't intercept at all. So this part, the following part, is going to make use of those those conditions. There are a few things to consider. First, for graph sketching, part 2, graph sketching. You have seen in the previous page how do I manage to get we have y, 0, x. No matter how, whether it's U curve or N curve, whether you have maximum point or minimum point, for this purpose, I'm going to use the U curve, but the N curve with the maximum point should work the same. And the same goes with only one root. No matter how the curve look like, a quadratic curve, you should have y-intercept. This is a time when this happened when x is equal to 0. Also, next we will have this part and this part, and in order to get these two values, x1 and x2, I would name it, is when y equals 0. Third thing is when, how do you get this turning point? This point. This is you're able to obtain from completing square, whereby fx is equals to ax plus p squared plus q. If you manage to express in this term, therefore this point would be therefore negative p plus q. A coordinate. There are times when you are asked to tell the axis of symmetry, and over the time, axis of symmetry is a middle point between x1 and x2. This is x equals to the negative p. Because the p could be a negative number, negative, you get a positive number for this instance. Let me have the same equation, given equation, or function equals to x squared minus 3x plus 2. If you were given a function and you were asked to sketch this graph without any other information, you know that the roots is 1 and 2 because I worked out previously, but just in case, assume that you doesn't know those information. Assume you are just watching this now. So how you sketch this? So first, to start with, would be, no, the color is different. I try to make it matching with color. Is when x equals to 0, because you need to find out what's the y-intercept. Find out what's the y-intercept. Simple. That's that. First step. When y equals 0. Well, when y equals 0, there are 3 methods for you to find out in the previous chapter. Straight away, you may use the equation. You may completing square, or you may factorization. But I think it's easiest you factorize them simply, or you may use a calculator to do that, to help you out with that. You times, you get minus 3. So you know that x equals to 1 or x equals to 2. First part, you find out what is when y equals to 0 here. Then, second part, right. Oops, the color is different because here is a here. Second is when x equals to 0, solution, which is here, sorry, I think it's here, when x is 0. This is even easier because in chapter 1 you have learned it. All you need to do is to map x into the function. So when x is 0, you put it into this equation, x equals 0, put it here, you get the answer. Straight away, f0, you will get 2. So you know this is 2 now. I will know now it's 1 and 2. The third one, the final one, will be completing square. I know it's a little bit tedious. To express it in this manner, minus 3 over 2 squared, subtract minus 3 over 2 squared minus 3x plus 2 plus a minus term, and you should be good at it as time goes on. And this one is 9 over 4, negative 1, 4. Negative 3 went missing because it's inside here already. You expand this part, you get back your minus 3, that's why you get equation. From there, you will find that a is greater than 0, therefore the point 3, 2 and negative 1, 4 is more than 0, meaning it point up, going up, going up is minimum. It's a minimum point. With all these 3 information, you will be able to sketch a graph. And you put into a graph form, this one will turn out to be 2, and x1 would be 1, a smaller value would be 1, x2 would be 2, And your axis of symmetry, this is a minimum point, which turns out to be 3/2. And the minimum will be -1/4. This is the axis of symmetry. Minimum point. It helps you for graph sketching. Now, last part for this chapter will be inequalities. Now, inequalities, I will learn by example. Whereby in this equation, in this part, is very much related to the previous chapter. Say, for example, an easy one. For example, find the range inequalities. Inequalities like, for example, you are given a function fx is equals to a positive x, positive a, x squared minus maybe 8x plus 2m plus 6. You are told that this function cuts the x-axis at two distinct, they say intercept, not a cut, intercept the x-axis at 2 points, at 2 distinct points. So I hope it will be this is what it means, distinct point. 2 distinct points. If it cuts at 2 distinct points, meaning it has to do with b squared minus 4ac is greater than 0. Yes, exactly, it's greater than 0. I'm sure you know this by now. With this keyword, straight away you want to write this down already. Because you are asked to find what's the range of m. Range of m so that you get 2 distinct point. Range of x. That's why you have this sign here. This would give you a range of m. Well, okay, let's work it out. So b squared minus 4ac, if you still remember, a general form for quadratic equation should be ax squared plus bx plus c is equal to 0 equation. So this is a, b, c. Compare it with this function. This is your c. This is my b is -8. My a would be 1. So b squared minus 4ac. So b would be -8 squared minus 4a. C greater than 0. So you solve this equation. Minus 8m minus 24 is greater than 0. This is 40 is greater than 80. 8m, sorry. So therefore, my m should be less than 5. This is for linear case, when m is linear. Well, we'll try to look at value when you have non-linear case. When the case is non-linear, when it's not linear, For example 2, maybe this is example 1. I'll try my best to include example in my tutoring so that I'll be able to finish within 40 minutes. Find the range for x for which 6 minus x, you have 6 minus x minus 2x squared will be greater than 0. Now how are you going to solve this kind of question? Find the range of x. Find the range of x. Range again. Well, you can't use this anymore because they never tells you whether it is you have two distinct point, one distinct point, or no root at all. They didn't tell that. They just find range of x. Now it's x. So to do that, what you do is you try to get a positive value of x squared, the highest number, to make it positive. So I bring it over the other side. It will be 2x squared plus x minus 6 would now be less than 0. So you need a negative value of this thing had to be negative. So to do that, next we will want to factorize them. You might need to put in your calculator to help you for the factor 2x, 16, you get 616 or 23. If you were to 2 and 3, cannot do with that. Then 3, 2, that will be 3 here, 2 here. This is a positive. So I would say plus 2 minus, so that's minus 3 plus 4. 4 minus 3 is 1, so you get this. Now, once you manage to factorize it, you need to have a graph. Now, not to say a graph, only the x part of it, whereby here, this is equal to 0, or this is equal to 0. You need to find what's the root, where the roots are. That would be, too long. Where's it going? That would be either here or here over the symmetry of x. This is x value. The y value, I doesn't need to draw that because I doesn't need it now. X could be negative 2 of the root and 3 over 2. A appear to be positive. A appear more than 0. So you will expect it to be a U graph. So therefore, this graph should look like a U graph. Okay. I think marks are given if you manage to sketch it. Since you are looking for less than 0, the part when y is less than 0 is here. Therefore, your inequalities or range of x for this equation would be between, therefore the range of x would be negative 2 less than x less than 3 over 2. It's only less than because only one is only less than, it doesn't include 0. So this should be empty point. So this is how you solve it. And this is all about chapter 3. Like my video, share it with friends. Sharing is caring. And it helps me to eat it. Really actually motivates me when I get the amount of like increases over time. Thank you. The question changes. Let me do it here. Over here. I mean, maybe separate is In the event where the question, if it were to ask for a value more than 0, we have more than 0. If the question asks for more than 0, and therefore your range of value, the curve should remain the same, just that the area will be different. Here is -2, here is 3/2. If the question asks for more than 0, the curve should be like remain, it doesn't change the curve. The area when it is more than 0, that would be the area here and here. Therefore, your answer would be different, and it would be x must be less than -2 or x must be more than 3/2. So the difference is obvious. It's so obvious that it's different as when the equation requires more than 0, the answer would be above the curve. And if the question asks for less than 0, that would be the area under here. Therefore, the range would changes. It's different.